Hello everyone. In this lecture we will discuss about some adsorption isotherm. So what is adsorption of isotherm? Uh, Isotherm is a constant temperature curve. So isotherms mean constant, iso mean constant and therm mean temperature. So these are constant temperature curves. For example, this is the equilibrium concentration and this is the equilibrium uptake, and suppose this is some curves which is obtained at constant temperature. So this curve is called isotherm. So isotherm is a constant temperature curve. Adsorption equilibrium study is used to plot adsorption isotherm. So usually adsorption equilibrium study is used to determine the adsorption isotherm. So this is the adsorption equilibrium study, equilibrium concentration and equilibrium uptake. So these are the adsorption equilibrium study. So with the help of adsorption equilibrium we can plot the adsorption of isotherm. The shape of isotherm decide whether the adsorption process is favorable or not favorable. So the shape of the isotherm, suppose if the isotherm shape is like this one, so the adsorption will be favorable. But if the isotherm shape is like linear, like this one, then the adsorption process will be not favorable. If the adsorption the isotherm is like this one, so the adsorption will be not favorable. So the adsorption is favorable in this case. This plot can be obtained from the Langmuir or Freundlich or Temkin adsorption isotherms. So these are the favorable adsorption isotherms. The shape of the isotherms decide whether the adsorption process is favorable or not favorable. There are various adsorption isotherms. So for example, the Langmuir adsorption isotherms, the Freundlich adsorption isotherms, and the Temkin adsorption isotherms, and many more. There are many more adsorption isotherms. Langmuir Freundlich adsorption isotherm, the combined Langmuir Freundlich adsorption isotherms, and many more adsorption isotherms. But in this lecture, our main focus is on the Temkin adsorption isotherms. If you don't know about the Langmuir adsorption isotherm and Freundlich adsorption isotherms, I will put the links in the description of this video. Watch it and you will completely understand that what is the Langmuir and Freundlich adsorption isotherms. These are the important adsorption isotherms. Now in this lecture we will discuss about the Temkin adsorption isotherm. So Temkin adsorption isotherms is one of the most important adsorption isotherm. And according to this model, the heat of adsorption decreases linearly. Is the adsorbate attached to the surface of adsorbent. So the heat of adsorption decreases linearly. Is the adsorbate attached to the surface of the adsorbent. So as the layer increases, is the layer of adsorbent increases on the surface of the adsorbent. Suppose this is the adsorbent and these are the adsorbate. This is the adsorbate layer. So as the adsorbate layer increase on the surface of adsorbent, the heat of adsorption will be decreased linearly. So this is exothermic process again. According to this model, heat of adsorption decrease linearly as the adsorbate attached to the surface of adsorbent. As the adsorbate layer increases on the surface of adsorbent, the heat of adsorption will be decreased linearly. So this is the main adsorption isotherm. This is the Temkin adsorption isotherm, and the mathematical form for this Temkin adsorption isotherm is this one. This is the non-linear form. This is the non-linear form of the Temkin adsorption of isotherm. So this is the QE again. This is the equilibrium. This isotherm is obtained from the equilibrium study. So first of all, this is the equilibrium. I will write it in some other color. Suppose this one. Okay. This is the A. This is the CE. The C is the equilibrium concentration. The QE is the equilibrium uptake, and this is the R is the universal gas constant. Its value is 8.314 joule per mole into Kelvin. The T is the absolute temperature or temperature in Kelvin. So if the isothermal study is at room temperature or 273 Kelvin or 25 degrees, so it will be 298 Kelvin or some other temperature. So this is the temperature of the experiment. This is the temperature of the experiment. The beauty is the Temkin constant, and it shows the relationship between the bond between it show a relationship between that how much strong bond is formed between the adsorbate and adsorbent. So this A is the equilibrium bending constant, and again this is the maximum bending energy. This is the maximum this constant, and this constant shows information, give us information about the maximum bending energy, that how much maximum energy can be released when atoms or molecule or ions are added or attached to the surface of the adsorbent particles. And this C is the equilibrium concentration, and remember this CE value is obtained from the adsorption experimental study, and when once we obtain this the adsorption equilibriums concentration, then we will get the adsorption equilibrium uptake. From this relationship you can get uptake is nothing but the initial concentration of the experiment, and this is the concentration of the component in the beaker at any time CT, and the volume of the beaker, and the mass of the adsorbent divided by mass of the adsorbent. So this CE is the initial concentration, and remember the Temkin adsorption isotherm is valid for the middle concentration range, mean that it is not suitable for very dilute solution. We cannot use this Temkin model for very dilute solution. Like if we prepare 1 or 0.1 ppm solution, and someone ask from us that find the adsorption equilibrium study or do adsorption equilibrium study for this 1 ppm or 0.5 ppm solution, so in that case our Temkin adsorption isotherm will be not very accurate. And if someone give make a solution of 5000 ppm or 10,000 or 7,000 ppm solution, and they ask from us that make the adsorption equilibrium study of this solution using the Temkin model, so our model will be not correct. The R square or the regression coefficient of our model will be not good. The R square value will be something like 0.7 or 0.6, so it will be not good for the higher concentrated solution and for very dilute solution, but it works between the middle range. Like it can work at 200 ppm, 300 ppm, 400, 500 to 1000 ppm or 2000 ppm. So from 100 to 2000 ppm this model work very well. So this is a good point about this adsorption isotherms, and this is the non-linear form. The beauty is the this work in the middle concentration range, so it means it work from so ppm to 2000 ppm, suppose ppm solution. It can work below this one also, like 50, 60, 70, 80, and about 2100. So it depends on our experimental condition and the amount of adsorbent present in the solution. So middle concentration range, BT is the heat of adsorption. It is nothing but enthalpy of the adsorption process. And again, this delta H or this BT show us that whether our adsorption process is physical adsorption or chemical adsorption. Remember, the heat of adsorption or enthalpy of adsorption, when it is between 10 to 20 joule per mole, 10 to 20 joule or 10 to 20 kilojoule per kilomole, then our adsorption will be physisorption or physical adsorption. And when the heat of adsorption is above 40 kilojoule per mole or 40 kilojoule per kilomole, or 70, 60, above 40 or above 20 kilojoule per mole, when the heat of absorption is above 20 kilojoule per mole, like 30, 40, 50 kilojoule per kilomole, then in that case the adsorption process will be chemisorption. The adsorption process will be chemiosorption. There will be a strong bond between the adsorbate and adsorbent. But when the heat of adsorption is very low, then very small or very weak van der Waals force of attraction will be responsible for the adsorption of adsorbate and adsorbent. So this is again the main reason is when the enthalpy change is very small, 20 or 15 or 10 or 5, even 1, 2 or 3 or even 0.1. So in that case the heat of the adsorption will be physisorption. But when the adsorption process, the heat of adsorption is very high, like 30, 40, 50, 60, then in that case the adsorption will be chemisorption or the chemiosorption. The chemical bond, the ionic bond or covalent bond or coordinate covalent bond or chelating reaction will be taking place between the adsorbent and adsorbate, and it depend on the heat of adsorption. And this is the Temkin constant. The A is the equilibrium bending constant. It is the maximum bending constant. It shows that how much maximum energy will be released when adsorbent is attached to the adsorbent surface. So this is again the maximum equilibrium bending constant, and it gives us the relationship between ligand and adsorbent or ligand and adsorbent or some other two surfaces. So this is the linear form. This RT divided by BT is nothing but the BT and heat of adsorption, and the BT, the linear form of this relation is this equation is BT ln A is the maximum bending constant, BT is the heat of adsorption, again BT, and C is the equilibrium concentration. And remember, this equilibrium concentration is obtained from this relationship. So this C is the initial concentration. It can be 100 ppm, 200 ppm. So the concentration of our initial solution will be given to us, and the volume of solution will be given to us. Suppose this is 100 ppm, 100 ml solution, 1000 ml solution, and the mass of adsorbent, it can be 1 gram, 2 gram, it can be any gram of adsorbent. And the CT, this concentration, which is the concentration of adsorbate in the solution at any time, and this concentration can be obtained from the UV spectrophotometer or some other other machines like conductivity meter or some other atomic absorption spectrophotometer. So you can obtain this from various machines with the help of various instruments. So once you get the information about CT, you will get the QT, the equilibrium uptake at any time. And once the concentration of adsorbate in the solution is not changes, once the concentration of solution reach to some constant value, then at that case the CT will be equal to CE, and it will be equal to the equilibrium concentration. And at that equilibrium concentration, the equilibrium uptake will be called the QE. And this CE and QE when plot, we will get the Temkin adsorption isotherms, and this is the QE, the equilibrium uptake, and this is the equilibrium concentration. This equilibrium uptake is obtained from C naught minus CE divided by mass of the adsorbent, and this is the volume of the solution, and this is the QE. This is the QE. So again we will draw a plot. We will get a plot. We will get a relationship between the equilibrium concentration and equilibrium uptake, and again this is also a linear line. This is Y, and you can see this is the mx plus C. So the C is the x-axis, this is the CE, and on the y-axis we will get QE. This is Y, and this is the y-intercept. Y-intercept is C is equal to BT ln A. So this is the slope. This is BT is the slope of the line. So suppose this is the slope of the line, BT is the slope of the line, and this is the QE, and this is the y-intercept, which is BT ln A. So BT ln A. Suppose the y-intercept is 3. So BT ln A will be equal to 3, and from the slope we will get this one. So suppose the slope of the line is BT, suppose it is 0.8, so we will get ln A is equal to 3 divided by 0.8, and e to the power this one, e to the power this one, so A will be equal to e 3 to the power 0.8. So we will get some value for the equilibrium bending constant. So and also we can get the BT value. Suppose we know BT is equal to RT BT. So if this is given to us 8.314, and this one is the temperature which is also given to us, and suppose the value of this BT's value is 20. Suppose this is 20. So we will get this BT by rearranging. We will get this is 20, and this will be equal to BT. So, and this is the R, and this is the temperature. So here you will get the Temkin constant. We can also obtain the Temkin constant. Thank you very much for your attention. If you are new to the channel, please like and subscribe.